In this video, we're going to be talking about correlations. A correlation is a measure of the extent to which two events vary together, and thus how well either one predicts the other. A correlation is a fancy way of saying relationship. That is all it means. If two things are correlated, they are related to one another. This means that if one of the variables goes up, the other thing is going to go up. If one goes down, the other one is going to go down. That's one way you can have a correlation. The other way you can have the correlation is if things move opposite each other. So if one goes up, the other is always going to go down. So a couple of examples of those that we'll use later on in this video when we talk about correlation coefficients. It could be weight versus exercise. Generally speaking, the more you exercise, the less you weigh. So if you work out even more for a month, your weight, you can assume, is going to go down. That would be a correlation between weight and exercise. When one goes up, you have a good idea the other is going to decrease. So that's one way it works. The other way, if they move together in some way, would be like height and weight. Generally speaking, the taller you are, the more you weigh. You don't see a lot of people that are 6'5" walking around weighing 100 pounds. You also don't see a lot of people that are 4.5 pounds that weigh, or 4.5 feet that weigh 500 pounds. Generally speaking, the taller you are, the more you weigh. The more height, the more weight. The less height, the less weight. That would also be a correlation between weight and height. So sometimes things move together, sometimes they're going to move opposite. Those are the two types of correlations. So we'll talk about correlation coefficients first. A correlation coefficient is a mathematical expression of the relationship. This is the number that tells you all about the correlation. A correlation coefficient is going to be an R, a negative R, not positive. It's going to be negative. And that is going to be some number between -1 and +1. You cannot have a correlation coefficient that is less than -1. You cannot have a correlation coefficient that is above +1. It has to be in this range. And this is going to tell you a couple of things. It's going to tell you the direction, whether things move together or whether they move opposite each other. It's also going to tell you how good of a relationship it has. Is it a strong correlation or is it a weak correlation? One thing to know off the bat is if you have a correlation coefficient of 0, it is not good. If the correlation coefficient is 0, it means there is no relationship, there is no correlation. So don't go for a 0. So again, two things that you know from a correlation coefficient. One is the direction. So that can be either positive or negative. One thing that really confuses people is they think positive correlation and they think this is a good thing. No, that is totally not true. Positive correlations are not good things. Negative correlations are not bad things. That's not what it means. What it means if you have a positive or negative correlation is just the direction. So if it's a positive correlation, that means they are going to move together. That means if one goes down, the other goes down. If one goes up, the other goes up. For example, height and weight. As you grow taller, you gain weight. If you get shorter for some reason, you're going to lose weight. They move in the same direction. That's positive. Not necessarily a good thing. It just means same direction. Negative means the exact opposite. It means they move in opposite directions. So when one goes up, the other goes down. That is what negative means. This is the exercise in weight. The more you exercise, the less you're going to weigh. The more you weigh, the less you probably exercise. They always move in opposite directions. So whether something is a negative number or a positive number just tells you what direction they go in. That's one thing you can tell from the correlation coefficient. The other thing you can tell is the strength, which is how closely they are related. It's basically how well you can predict one variable if you know the other variable. So the stronger the correlation, the better you can predict one if you know the other. The way you tell the strength of a correlation is the absolute value of the number. So you ignore whether it's a negative number or a positive number, you just look at the absolute value. For example, a correlation coefficient of negative 0.9 has the exact same strength as a correlation coefficient of 0.9. It doesn't matter if one is negative or one is positive. It's the same number, absolute value. That's what matters. For strength, what matters is how close it is to 1 or negative 1. The larger the absolute value, the better, the larger the strength. So you cannot get a stronger correlation than negative 1. You cannot get a stronger correlation than positive 1. That is as strong as it can get. You cannot get a weaker one than 0 because you can't get a smaller absolute value than 0. So you want it to be as close to negative 1 as possible or as close to positive 1. As far as strength is concerned, it does not matter if it's negative or positive because, again, you're only looking at the absolute value of the number. The way that we look at correlations, the easiest way to understand what you've got is to look at a scatter plot. So I'm going to draw a few scatter plots. So what happens with a scatter plot is you put every person you talk to or every situation you analyze, whatever is in your correlation, you put it on a graph. So for this one, we'll say that we'll do a positive correlation first, which would be height versus weight. So for your scatter plot, you've got your weight, you've got your height. Generally speaking, if someone is, say, this height, they'll be potentially that weight. If they're shorter, they're going to be lower in weight. And you basically just go around and ask everyone, hey, what's your weight, what's your height? And you create a scatter plot with all of these dots of what people said scattered, plotted along the graph. A correlation like this would actually be fairly strong because you can see the line going this way pretty easily. If it is a correlation of 0, or even if it's a correlation of 0.1 or 0.2, the dots are going to be much more spread out. They are not going to be this in line. So this would be a good scatter plot. And your book also mentions some scatter plots. If you are going to have a negative correlation, the dots are going to be in the opposite direction. So again, weight and exercise would be a negative correlation. The more you weigh, the less you're exercising. If you're exercising a lot, you tend to weigh less. This is not quite as strong of a correlation because the dots are not as close together. But negative correlations are going to be high in one area when they're lower in the other because they move in opposite directions. In your notes, you need to have the definition for correlation, definition for correlation coefficient. It's negative r. It can be between negative 1 and 1. 0 means no correlation. If it's a positive correlation, they're always going to move together. If it's a negative correlation, they're going to move opposite each other, like weight and exercise. And this correlation coefficient is going to tell you two things. Besides this direction, it also tells you the strength, how closely they are related to each other. The larger the number, the absolute value of the number, the stronger the relationship. It's easier to say, hey, how much do you exercise? Okay, I can guess really well what your weight's going to be. In this case, not quite as much because, again, not as strong. If you exercise this much, I'm going to guess your weight is somewhere in this range. If you exercise this much, it's going to be somewhere in that range. If you weigh this much, I bet that's how much you exercise. That is how you use a scatter plot. And that is correlations.